Welcome to the CaptureSDK and SocketCam integration tutorial for iOS. We will show you how easy it is to integrate barcode scanning into your app using CaptureSDK with SocketCam, giving your users access to Socket Mobile's powerful camera and hardware-based scanners. This task can be completed in under half an hour. Let's begin. For this tutorial, we have created a project titled Mini Entry in Xcode. To follow along, you can use your existing project or make a new one like ours. If you need more time with a particular step, feel free to pause or replay the video as needed. We are running Xcode 15 on macOS Sonoma and version 1.9.18 of Socket Mobile's CaptureSDK. As you can see, this app only has one screen, and every line of code relevant to SDK integration is contained in one file, the main view controller. To begin, you will need to acquire the iOS SDK from your Socket Mobile developer account. Here, we are using Swift Package Manager, SPM. In your project, find the Package Dependencies tab. Copy and paste the SDK URL here and add the package. Before using the SDK, be sure to add the following 4 items to the app's info.plist file. Next, you will need to go back to your Socket Mobile developer account and register for a new application. Once the form is submitted, you will be given a new app key with related app info in a sample code snippet. After importing CaptureSDK into the project, you are ready to insert code to initialize Capture. We are using Capture Helper. To do that, you will need to implement the Capture Helper delegate. The Capture instance is a singleton pattern, so we prefer initializing it in the main screen while the app's main view controller is loaded. Make sure that the Capture Helper is running in the main queue and push the delegate to the view controller where it can be easily used. You can now copy and paste the app info from the Socket Mobile developer account and open Capture by calling the Open with App Info method. Because SocketCam is built in and does not require an external device, it is always available to you and your users. However, SocketCam must be enabled in the app before it can be used. To do that, create a function called Enable SocketCam and use Capture Helper's getSocketCam status method to get the property SocketCam status. Set it to Enable if it has not already been set. This is a persistent setting that only needs to be set once. Make sure that the button is also enabled. You can now call the function once Capture is opened. Next, trigger the SocketCam viewfinder by implementing Capture Helper Device Presence Delegate. This delegate allows us to access available devices, including SocketCam, and provides 2 delegate methods: did notify arrival for device and did notify removal for device. In Mini Entry, we have already set up a Scan with SocketCam button in the app. When pressed, SocketCam will call the setTrigger method to launch the SocketCam viewfinder. Interesting note, you can also use the hardware volume keys on your device to trigger SocketCam. When we call the setTrigger function on the SocketCam device type, it will return a SocketCam view controller that we can use to present the camera viewfinder. Please note that as of version 1.9.4, you can customize the size of your viewfinder. Here, we use a UI sheet presentation controller to present the viewfinder at the bottom half of the screen. At this point, the trigger does not work. The SocketCam device you set the trigger on is still an empty object. To make the trigger work, you will need to implement the didNotifyForDeviceArrival method. After SocketCam is enabled, a SocketCam device is returned as a Capture Helper device through the device arrival event. You can check the device name. If it contains SocketCam, update SocketCam device to reference the returned device. Time for a quick test. Compile and run the app. The camera viewfinder should now be functional. To receive scanned data, use the Capture Helper device decoded data delegate. Implement the delegate method didReceive decoded data to retrieve data and populate the barcode text field. Please note that the decoded data is a UTF-8 encoded string converted from the raw data by Capture Helper. Once you receive the data, you will want to dismiss the viewfinder automatically. To do this, you will need to keep a reference of the SocketCam view controller, dismiss it, and set it to nil. Let's run a quick test. SocketCam is working. By default, users will have access to the C820, but can also upgrade to the more advanced C860 for faster scanning speed and better low-light performance. You may also notice that with no extra code, Socket Mobile hardware scanners also work seamlessly with the app. Here, we are using the S700, which we have connected through the Socket Mobile companion app. As you can see, it works perfectly. There is, however, one thing to note. While SocketCam is always available, the status of a hardware scanner can change at any moment. To compensate for that in the UI, you will need to create a scanners array to track connected devices. Use a display scanners function to update the current device label. This function will be called anytime a device arrival or removal event occurs. For device removal, notice that strings match the removal devices and are subsequently removed from the scanner's array. Now, let's compile and run the app. As you can see, both SocketCam and the S700 are running, and we can receive data from both. When we turn off the S700, the scanner is removed from the list. Congratulations! You have successfully integrated SocketCam and Socket Mobile hardware compatibility into your app. If you require further assistance, please reach out to us at the developer portal at socketmobile.com.